This lesson is about the sine law. So we can use the sine law for any triangle that is not a right angle. Technically, you can use it for a triangle that is a right angle as well, but if that's the case, we would just use our primary trig ratios or SOHCAHTOA. You are going to notice a couple of things. So the first thing that you're going to notice is that I am always going to be labeling an angle with a capital letter, and the opposite side is a side length with a lowercase letter. So angle B is right across from side length B, and angle C is right across from side length C. When you're doing the sine law, you must know a pair. Now, I have written the two formulas for you, so it is really the exact same formula. You can just choose to write it either way. So sine of the angle divided by its matching length is equal to sine of another angle divided by its matching length. Or you can put the length on the top and the sine of the angle on the bottom. Either version of this will work. I will typically be using the first version just because if I'm going to memorize one, it doesn't matter which one, and I've memorized this one. Just like with primary trig ratios or SOHCAHTOA, we can use the sine law to find side lengths or angles. This first example, we're going to be using the sine law to find the unknown side x. I know that I can use the sine law because I do know a pair, so I do know this angle of 44 degrees with its matching length of 54 degrees. So, or 54, sorry. The first thing that I'm going to be doing is writing my formula. So sine of A over A equals sine B over B. Now, the letters in this formula don't matter. If your triangle is labeled CDE, it could be sine C over C equals sine E over E. I just always use A and B because you can label a triangle however you want. So sine of my angle, remember, an angle always needs to go after a sine, cos, or tan. So sine of 44 divided by its matching side length of 54 is equal to sine of my other angle, so sine of 50, divided by its matching side length x. Now, when you're solving these, you are going to be cross multiplying. So what I'm going to be doing is taking this x and multiplying by sine 44. That is simply just x sine 44 is equal to, I'm going to be taking this 54 and multiplying by this sine of 50. Now at this point you can go ahead and turn all of these to decimals, but it does mean that you're writing out more, rounding more, and potentially your answer could be off by up to a couple degrees or some decimal points depending on what you're solving for. So I'm just going to go ahead and leave it just like this for now. If I want to get x by itself, I need to divide both sides by the sine of 44. What I'm going to be left with on the left-hand side is simply my x, and on the right-hand side, I'm going to be left with 54 times sine of 50 divided by sine of 44. By this point in time, you should know what you have to type first on your calculator, and you should be able to get an answer of 59.5. There are no units given in this question, so we will just leave it like this. Again, for this question, I do know a pair, so I have an angle of 47 degrees here, and I know its matching side length of 78, so I can go ahead and write out my formula. Sine of A over A is equal to sine of B over B. Now I can go ahead and plug in my information. Sine of 47 divided by 78 is equal to sine of x divided by 106. You'll notice that in this example, even though I'm finding an angle, the steps are the exact same. I will be cross multiplying. So again, I'm going to do 106 times sine of 47 is equal to 78 times sine of x. If my goal is to get x by itself, I do need to divide both sides by 78. At this point in time, a lot of students do make the mistake of attempting to divide out the sign. Unfortunately, we cannot do that since the sign and the x must stay together. So, on my calculator, when I do 106 times sine of 47 divided by 78, I will get 0.993890927 is equal to sine of x. It is important that we keep at least 5 digits when we're doing this, otherwise your answer could be off by quite a bit. You will probably remember from our last chapter that if you are attempting to find an angle, you must use sine inverse. So in order to get x, we will need to do the sine inverse of 0.993890927, and we will get x is equal to 84 degrees. I have said multiple times in this lesson that we're allowed to use the sine law if we know a pair. They can trick you, or I can trick you, when giving you a diagram. In this particular example, we know this angle, but we do not know its corresponding side. We know this angle, but we do not know its corresponding side. And we know this side, but we do not know its corresponding angle. Many students think that this means that we cannot use the sine law, but we are trying to trick you when we give you a question like this. It is very obvious that we could figure out this angle. We know that a triangle has 180 degrees total. So if we're attempting to figure out this third angle, we could do 180 subtract the other two angles. 180 subtract 71 subtract 34 is 75. In this way, I can see that now I know this angle is 75 degrees, this side length is 32, and I now know a pair, and I can continue to set up this question. I will not be solving this question, but I will set it up for you. So if I was attempting to find x, I would be saying sine of 75 divided by its matching side length of 32 is equal to sine of 34 divided by its matching side length of x. We could then start cross multiplying and solving for x like we would.